Okay, hello, pupils. Let me... Hello, Mr. You have a very gay name. I can completely picture it. Yeah, let me do some preparatory work. Hopefully you have a lot of viewers soon. Because it's kind of better, I guess, for viewers if they are here from the start. Okay, this is not related to Vulkan. Let me create a, I don't know, let's even go to C++. Make a new something. Make dir ECC. ECC already has some certain stuff. I'm just going to call it numberwall. So the other day I saw the most recent Methodologer YouTube, and I thought, well, that might be interesting to test on the work that I did for elliptic curve cryptography. At some point I did an investigation on elliptic curves. Where do we go to? Reference manual. Cracking B, I think. Yeah. So I did a brute force count of the number of solutions of this equation over some Galois field. But don't worry, you don't need to understand that. The point is that the question was what comes next? And that seems to be very related to this number wall thing. So I did some analysis here and I saw patterns, and in the end I figured out a program that does this. If you ask me, it should be possible to reproduce this simply by entering the first numbers and then making a number wall. So how does this work? And I could apply that on all the other sequences as well. Yeah, for that you need to make a little file. Hey Martin, yeah, can you read the description please? So I'm going to do something small-ish. It's warm here. I'm just dressed too hot. I had hoped I would run up to 20 viewers very quickly, but okay, we'll just start. Not going to wait for it. Okay, yeah, well, I guess it would be better if people had seen this YouTube from Methodologer, but let me quickly explain. The idea is, let me make a file, let's call it main. The idea is you have a number of zeros, infinitely many. Below that, a number of ones, infinitely many. And below that, we have a series, which I'm gonna copy from here. Shall I just use this? Yeah, why not? Let's copy the first 15, that should be enough. 16, whatever. So the numbers are not immediately too big. Let's get rid of the index. Now I want to make a table where we put in these numbers in the same column. They're a bit wider than the ones, so let's shift this over a bit. Oops. Undo. And there's a Control V Y. PP. BBB. Well, and so on. I'm not going to type them all in. Now we're going to do the following trick. Anywhere in this table, we're going to fill this table. It's like a wall. That's why I call it number wall. We're going to fill this in a way that at any point where we have some number, let's say we have here A, B, C, and we have here D, and we have here an E. It's a cross, okay, but for example, B could be this one, and then A is this one, and C is this one, D is this one, and E is this number, yes? Then at any point, the following equation must hold. What am I doing? A times C plus D times E equals B times B. Now, unless we have to do with zeros, and I hope / don't think we will have zeros here, this is pretty straightforward because we are just simply generating the E's from A, B, D, and C, which we already have. Note that for this cross that I just pointed out, this works. 1 times 1 plus 0 times whatever is 1, and that equals this one squared, right? So it already holds because of the zeros at the top. Next, we want to find, let's say, the number below the 8. Well, that's going to do this E, so let's solve the E. Subtract A times C from both sides, and then divide the whole by D. And then we have E. So can I do that for my head? The B is here, that is the 8. So for that below the 8 we get 8 times 8 minus 4 times 4, all divided by, and the D is 1. Yes, so the D is here, A is 4, C is 4, and B is 8. And now we're going to complete the cross. If you calculate this, I need a calculator. Oh, you have a calculator here. Bleep. Calculator. How awesome. 8 times 8. Why am I only seeing 8 times? Oh, like that. I need minus 4 times 4, well that's 16, equals 48, divided by 1 is 48. So we get here 48. below this 8. Well, and so on. I'm not going to do that by hand, of course. We're going to write a little program. So we need a two-dimensional array. I'm going to make it a vector of a vector, so I can grow it indefinitely. Or shall I just make it a single vector and make it a pseudo two-dimensional thing? If I do that, I'm limited, but that's okay. It's okay with me. Okay, so let's say, well, this is a comment, otherwise it doesn't compile. Well, we're going to do this object-oriented, of course. So we're going to have a class number. That might feel very silly, but if you want to do object-oriented, you need a class for everything. So this 16 here, for example, is my number, and that has a value. And I'll already give away that counterintuitive. All numbers will be integers. Even though we are going to divide by something here. So in this case we divide by 1, so obviously it was an integer. But if you go lower, we're going to divide by an integer larger than 1. And still the result is going to be an integer. We'll add an assert to check that this is correct, but it is going to be correct. So I'm going to store all the numbers as unsigned longs. Call that value. Moreover, we might have a number and just want to know which column it is in. So let's number our columns, and then of course we start at 0. 0, 1, 2, 3, 4. Let's make the spacing the same, and that so I can at least add 4 of these. So I'm going to add some spacing here. Five, 6, 7, 8, 9, 10, and so on. And that's the column, and then yeah, we also have a row number. So let's shift the whole thing a little bit, and then put the row numbers in front of it here. So start with row 0, 1, 2, 3, and so on. Okay, this 48 belonged was really there. We also have numbers that we don't know yet, so maybe I want to have a special value for that, but I don't know what. I don't like magic values. We have enough memory, so let's just write everything nicely inefficient and large. Has value, so has value starts as false. We create a thing, then the value doesn't even care. I don't care about value at that point, so I'm not even initializing it. And we have, at the moment we initialize it, I'll give it an integer row and column. Yeah, I'll put row first, why not? Column. For clarity, let's shift this again. This is the column. And this is the row. Yeah, I like my ASCII art, so I'm gonna make it even more beautiful by adding here columns. Not there, so that's better. What other clauses do we have? Well, maybe we're going to have a cross. I don't know. Seems unlikely. Yeah, I'm not going to have a cross. Maybe it's going to be extremely simple. Maybe it's not even suited for object orientation. We do, however, have an initial series. So again, in the case the people that joined later might have missed it, we have a very mysterious sequence here, which is related to cryptography. And it took me forever to figure out how this continues. And even still, I do not really understand how that worked. I'll just briefly mention where those numbers come from. Well, that's the calculator, don't need it now. The idea is as follows. We have an elliptic curve, which is this equation here. Y squared plus xy equals x to the power 3 plus 1. But x and y are not integers or floating points, not even complex numbers. No, they are elements of a finite field. So the multiplication and addition is defined as is division, etc. But there is only a limited number of elements in them. In fact, there are 2 to the power m elements in that field. There is a way to construct that, and well, this website that I wrote describes it, but it's not really relevant. The point is that you can ask how many solutions are there. Well, there are obviously a finite number of solutions because there is only a finite number of x and y values. There's both x and y can only have 1 out of 2 to the power m values. So there is never going to be more solutions than 2 to the power 2m, or the square of 2 to the power m. In fact, it's much closer to 2 to the power m plus 1. Okay. You can brute force, well, for a low m, so for small finite fields, you can brute force compute how many solutions there are. So here's m, 2, 3, etc. And then I use my PC to brute force find how many solutions there are. Now, if you want to do cryptography, then the demand is that for large m, say by the time you're at 2048, you have an incredibly amount of possible solutions. But in order for this elliptic curve to be cryptographically safe, that number must be a prime number times a small prime number. For example, 3 times a very, very small prime. 3 times a very, very large prime number. So the step 1 is then to know how many solutions are there. Now, wouldn't it be nice if we just had a formula for that? Now, this is a very specific elliptic curve, of course. There are not even any parameters here. Normally you do have an a and a b. But skipping that, the question is, can we find a formula for this series? And that's not trivial, is because I did all this work in the past trying to figure out what pattern I would see in it. And then eventually I came up with this series, which is added to the integer number database. So it didn't exist yet. And then eventually I got a program that generates these numbers. But I have to admit that I never really understood where this come from. So it ends here, 2008. And now I'm going to finally deck it for real. So now things come simple again. I mean, now all we are going to do is use normal integers and multiplication and addition. That's it. Middle school and stuff. But I have good hope that we will be able to find out what is the next number in this series and the next, etc. So to summarize, these numbers here are the number of solutions of a certain elliptic curve over a graph field with characteristic 2 and 2 to the power 2 elements of the base field, and 2 to the power 3, 2 to the power 4, 2 to the power 5, etc. And now you can forget that. So you're just going to find out how this series continues. Let's say we are breaking the Enigma code. What is the next number? Okay, well, number. What we need, of course, is a list of these numbers somewhere in our program. Well, it's a finite list. I'm just going to add it as an array, or not. Array, also unsigned long. You know what? Maybe later I want to make it an unsigned long. Maybe I want to make it an large number with some kind of large number library, so you can, like GMP, something that can grow indefinitely large. So maybe it's better if I use some custom type. I already called this number. I want to call it number. So I'm going to rename this one. So using number is unsigned, using unsigned long, and then I have to only change it in one place. And this is then I don't know, a field. I mean, an element. Okay, anything is good. So now that's an integer number. And my array also has integer numbers, and well, about, I think it was 16. So let's call those, this is our secret series. It's a start series. I'm just calling it series. Doesn't really matter. Normally naming is very important, but I really don't want to spend too much time on that now. I'm just going to put that in here. And then I'm going to replace all the spaces with commas. And we do that. Substitute 2 spaces or more, 1 space or more, with comma space everywhere, except for the first place, obviously. And then we can start writing our program. Oh yeah, well, we need another class. We need a wall. Maybe we need a row actually. Yeah, we need rows. Row. So a single row is well, there is a row, and then there is a row below that, and so on. A single row exists of a dynamic array, aka a vector of numbers, also values. No, not numbers, elements. And I don't know much languages. I know English, Dutch, of course, and C++, C. I have programmed in a bunch of languages in the past, but I forgot all of them again. I coded in I don't know, Basic, GFA Basic, several assemblies, Fortran, Pascal, Java, PHP, but I forgot all of them. Now only C++ is left. I think that looks good. Row is a vector of elements, right? Now, element needs a constructor. If we construct an element, then that means that we just want it to be initialized. But we also have uninitialized elements where I don't know the value. So I'm having a default constructor. Default constructor means a constructor without any arguments. And then I use the compiler generated default constructor. So this default means whatever the compiler normally generates. And I think that means that it will, because I told it, so it will put false in this boolean and the rest is, I don't know, undefined, I think, because there are built-in types. But I also want to have, well, maybe, I don't know yet actually, but maybe I want to create an element, construct an element with a certain number as a value. And then I also wanted to know the row and the column. So I have the convention of starting these things as an m underscore so it doesn't collide, although I think these days might even compile if you call both the same name, I don't know. M call, and then nobody, and I still have to initialize the value. Well, this must be in the order that they are declared, so the m value must come before row. And I'm not adding here m head value, so that would stay false, but now we have initialized it. So that comes before m value. And what is it? True, of course, because now it has a value. We just gave it a value. Also meaning that it is initialized. Okay, well, we're also going to want to assign to it, but the compiler is going to generate an assignment operator, so I don't have to do that. That should just work. Now the row, yeah. I don't know yet what I want to do with the row. It's not super likely I want to initialize it from in one go, because we are going to generate all the rows. The only row that I really know is this one. Well, and all the ones and zeros, of course. You have to set a limit, I'm afraid, on since this is the last number that I know for my series, I cannot generate a number below it. If I want to generate a number below this one, I need to know the next. And that's what we are looking for. So I cannot, you know, it's just a row can never have more than 16 elements. There's 16. Let's fill them all in. So even though the wall is infinitely long, we're only going to store the first 16 columns at most. Simply because that's what I started with. Let's see if it indeed is 16. 11, 12, 12 even. 13, 14, 16. Yeah, just kidding. 0 is the first, so this is number 16 in total. Index is 15. And yeah, we do not like hard coding. This 16 here is rather arbitrary. I just completely arbitrarily copied the first 16 numbers from my table. So let's give that a name as well. Instead of hard coding 16 everywhere, make that a const expression. I call every integer, even these integers are all positive. Certainly the number of initial elements is positive, but I don't care, I just use int. Even though an int can also be negative, there is no reason whatsoever to make it an unsigned int here. As long as the int can fit numbers around 16, and they can. So I have a const expression int, and I call that number of initial values. Is that ridiculous long? But at least you'll never forget what it is. And then I'm going to use that here instead of the hard-coded 16. And now, like I said, we have a number here already. Might as well add a row, the raw type of a row. Let's call this a raw row. And that is then an array of number of this size. Okay. But then now I am storing numbers, and I wanted to store elements. I don't know if it makes sense, but if I want to store elements, I cannot define it here. I have to define it below element, otherwise element doesn't exist yet. And then here I'm going to use raw row. So raw row is now an array of number of initial values elements, okay? And then this, the series, the initial series is also a raw row. I'm going to call this initial values. Could call it top row, could call it, I don't know, number of solutions of the elliptic curve. Everything works. Well, maybe I want to do like this. Initialization of an array. I think we made a good start. We have a few classes. Okay, still cannot construct a row, because now we don't have a constructor. Or yeah, well, we do, but no, it's actually no problem. Well, yeah, it is, because I want to initialize it with this thing. So we have a raw row here, and we have a raw row here, and I want to be able to construct it from a raw row. Public. So we make a constructor for the row that takes a raw row by const reference. And we can just copy that because they are the same type. Okay, the next class is the wall, the number wall. Let's call it number wall. Okay, so for the people that missed this, I watched YouTube yesterday of the methodologer who explained how number walls can be used to find the next of a series. And I have a very interesting series that took me like a year of work, if it wasn't more than a year, to find the next number. And I think that the number wall is going to be able to crack it. I'm almost sure. And that will give insight as well. So I'm really interested in this. Okay, the number wall exists of a bunch of rows. In this case, it's definitely a vector because I don't know how many rows, I mean. A vector of a single row is plural rows. Okay, so that works. Then we need some includes. I'm going to write IO. We did use a array type and we did use a vector type. What else did I use? Nothing, I think. Okay, we're going to create a number wall. I'm just going to call it wall, otherwise it's maybe a bit too long. And I want to just initialize this thing from initial values, which is a raw row, so I need a constructor for the number wall that also takes a raw row. Also by const reference. And this is our initial values thing. I'm just using initial values here as well. Even though it's a global. Maybe it's going to warn us that it shadows this global, but if that is the case, then I'll rename it. Okay, this, of course, I can do it here in the body, but if you can do something in the initializer list, that's always, yeah, better, by lack of a better word. So we have, just like here, I want to initialize this, you do it behind the colon, that's called the initializer list. If there are multiple variables here, like here we had 4 variables, you just put commas between them. And then the body stays empty. That's what you see in most constructors. So also here I want to construct this vector in a way that it is bang constructed correctly. How do we do this? Well, we need to tell the vector that we have a single element. Namely the first row. Oh, that's not true. We have 3 elements. Might be harder to do in the initializer list. Yeah, probably not possible. Let's do it like this. I'm gonna create 3. Now we get a vector initialized with 3 makes 3 rows, and each row will be default initialized, and we don't have a default constructor. Oh, that's problematic, isn't it? I think you always need to have a default constructor in a vector, or not? Not really true, of course, but then it becomes very complex. I don't want to make things too difficult for this. Let's just add a default constructor here. So this default constructor, default also because the compiler is generating it, will use the default constructor of raw row, which is just a standard array, which means it will fill the whole array with number of initial values using the default constructor of element, which means it will fill the whole thing with elements that do not have a value. Well, I mean, has value, not had value. So we're going to fill it with rows that have 16 elements, but none of the elements really has a value. It's going to say we don't know what the value is. That we can do. Then we have 3 of them, but now we need to put something in the body because we really want to give it the value. So I'm going to run over each of the rows. Let's call this row is 0, row is less than 3, plus plus row. So row is now running from 0 and then 1 and then 2. And I'm going to fill the row at this index. How do we do that? Because m rows with a given index is row. And a row is a class that contains a raw row, which is a standard array. But we don't need to know that, we just need to know that it is a row. I want to fill the row with all zeros. Well, let's just make a fill all the elements with a given number. How does that sound? That doesn't really work for all the rows then, because we need to call fill for the first 2, but we need to fill it with these numbers for the third row. So maybe no loop. Just simply row 0, fill 0. Rows 1, fill 1. M rows, and while I'm doing this anyway, why not fill initial values? So just make it work, right? So this must fill the first row with all zeros, and then the second row with all ones, and then the third row with the initial values. That's what I want. How can we make that work? Well, the 0 and the 1 are an integer, but integers are automatically converted to unsigned longs, if that's the only option. So it will just become a number and call this function here, the first 2. So we get number is 0 and number is 1. Let's implement it, not in the class for a change, but outside the class. You do that as follows. Put in front of it that it is a member function of row. And we're going to run over all the elements. I'm just going to run over all the elements by index or column. Column, why not? So column runs from 0 to the number of initial values. Plus plus col. And then we have m values col is number. Okay, something is wrong because it does not contain a number, it contains an element. Can I assign a number to an element? No, we cannot, but we want to because it looks cool. Or not. No, we also want to initialize row and col. I guess that the row itself must know which row it is in order to do that. Maybe we should just remove row and col. I don't know. Let's keep it though. Let's keep it. So this thing must know which row it is. Which means that we have to pass that as well here. Now we used a default constructor for the row. So that won't work. Okay, now my C++ knowledge is lacking me. I'm pretty sure there's a way to initialize the first 3 elements of something with simply a sequence, an integer sequence. But that is super complex. I would have to look it up, and then you would have to stare into a non-changing screen for half an hour before I figured that out. So I'm going to again keep it simple and not do it in the initialize list, but do it here. So this indeed is using the default constructor, and I am going to add a for loop. Where we just simply set the row afterwards. So now m rows row is a row because m rows is a vector of rows, and then after the square bracket thing we get this row, and then we call on this row object here, we call set row, which doesn't exist yet, so I'm going to add it. Set row, which takes a row and which then sets the row number. Then fill already has the row. So I can assign an element. I'm just going to construct an element in place here, the temporary. And the element is done, then copied to the m values row, which is a standard array containing elements. We had an element constructor here that took the value, which is a number, and the row, which is the m row here, and the column, which is this column here. So this way we fill the elements of this row. But we did something else. We called fill with initial values, which is not a number. So we need another fill that is called overloading. You name the same name, but the argument as a different type. So the type is obviously the same as that of initial values, so that's a raw row. We pass it by const reference because a whole row copying by value is a waste. You might as well pass a reference. I keep call everything a row. If it's an integer or a raw row, I don't care, it's a row. A normal row is a row is a row, an index row is a row. And now we have to fill it. Well, this is m values. Wait a minute. Yeah, row is already set. And in this loop, the loop down there. And now we set the values here. So m values is row, and this is row. You can just assign it. Now it will copy the array to the array in our row class. Okay, now we initialize the first 3 rows. Now it's time to print it, right? We want to see what we did. So we're going to do standard cout print the wall. Okay, standard. No need to flush. I'm just going to print a new line. Now this is going to give us a compiler error because our program and the compiler has no idea how we want to print a number wall. So if I want to do it like this, and we could also do it differently. I could just do wall print. But if I do it like this, it has the advantage that we can also print it to another ostream. We can specify the output. We can write it to a file maybe. So I like this. And in order to make that work, we have to add a friend to the number wall as follows: friend standard ostream reference operator less than standard ostream reference os comma number wall const reference. Which then must return OS and then do printing to OS here. Let's try to compile this and see if it prints here. I'm just going to compile it on the... well, don't need C++20 here, but why not? Let's compile this. Error, could not convert 4 from int to element. Ah, right. We have a major problem here. The raw row is just a raw row and not an element. So sorry, what exactly was that problem? Oh, I was confused. I forgot to add the declaration of this second fill, the overloaded fill. So always look at the first error because the rest may be nonsense. Although I'm not sure yet, but definitely always fix the first error first. So I added this overloaded fill here. And, well, you have to declare it as well in the class. And it was not nonsense, but now we get still the same error, right? Well, I hoped that wasn't the case, but it's complaining here about it cannot convert 4, which is an int, to element. I understand that, but I want to know why it's trying that. It's probably trying that because exactly at that line is what I'm doing. Yeah, raw row. My raw row is an array of elements. Yeah, that's not what I wanted. No. The raw row The row contains numbers. That's why I put the row in front of it. But in the end, I want to have elements in a row. Well, I'm not going to do anything difficult. There is no way I can get those m rows and cols in if I do not, if I put an element here. So this is going to be indeed number. The row is just a number, and I'm putting it here. Now we get some other compile errors because this is no longer an element. I want to see those compile errors. Okay. It says values call element. Yeah, so now we cannot put an element in a number anymore. So values really must be an array of elements. Now note that this you have to put something here, and I don't want to put a hard-coded value, so I use this constant. But it's dubious if I want to do the same here, because what we're doing here is we just run over all the columns of this array here. So you could as well write mValues.size here. That's going to result in exactly the same assembly code because it knows the type of mValues. The type of mValues is standard array, which with this size. So this function call between quotes is just returning this hard-coded template value. So it's going to in assembly is going to be a literal 16. But this is maybe better readable. And now you do not have to ask yourself, yeah, but is this value not too large for the mValues array? We might get an overflow of the value of call if a number of initial values is larger than the size of mValues. So this looks better, if you understand what I mean. It looks... you don't have to ask yourself if this is going to give an array overflow. I'm just going to try to compile until array must be initialized with the brace and close initializer. Yeah, that's true. That is very true. Gotta wonder if that works. I was wondering if it works and it doesn't work. Could not convert row from const row blah 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 to element. Yeah, the types are not correct anymore. Our mValues is now an array of element, and the row is an array of numbers. So it cannot do this anymore on the initializer list. So we do not just going to do it in the body. So let's do this again like here, I guess. Thanks, Hayratin. Where the number is now the row at index call. Are we even using this? Constructing a row from a raw row. I don't think so. Let's not add things that we don't use. I mean, I don't know. Might be confusing. No match for operator, for the assignment operator. Operand types are standard array element 16 and const raw row. It's basically the same error. So this is much like the fill, which we want to keep. Yeah, this row here was raw row, and then, well, maybe I should do it like that. Keep calling raw rows. In the case of a row, we assign to m values by column, constructing an element from the number, from the raw row, and then passing the row that we know that it is, as well as the current column. And then it compiled, so indeed we did not use this constructor. And then let's run it, and it prints here, yay. Okay, I'm gonna go over it again quickly, so everyone knows where we are now. So we have this series. I want to know what is the next number in the series. You're going to do that with the so-called number wall, which means we're going to generate this wall, which has a bunch of columns and a bunch of rows, using the fact that every cross of numbers has this relationship. The E can be calculated from the numbers above it and the D above the B, like this. In order to do that, well, we don't know, these are 16 numbers, so I hard-coded it here. And we're going to store the numbers as unsigned long, because despite that we're going to divide by D, these are going to be integers anyway, I predict. And the raw row is just the type that we use. Is an array with 16 values and storing an unsigned long. Then we have an element that is one element of a cross or one element of the wall, which can either have no value or it can have a value. If it has a value, then this is relevant, and we initialize which row and column it is in. The default constructor constructs elements that has no value, and this one constructs elements that do have a value. Then we have a row. It's a single row of the wall, which contains 16 elements, and it remembers which row it is. And we have a manipulator to set the row value, because you must begin with the default constructor and could not initialize the row immediately. We have now two fills, one that fills it in with all, well, the same value for all the elements, which we need for the first two rows, all zeros and all ones. And then this one is being used to fill in the initial values, which are given here. These are implemented like this, overloaded function. Then the number wall itself consists of a vector of rows. Also, the number wall is constructed from the initial values, and the constructor is then filling all zeros, all ones, and the initial values in the first three rows. And now we're going to implement the printing thereof, so we can see those first three rows. Now, if we would want to print anything here, of course we need to give this a name. Let's call it wall. I would have to say wall dot and then mrows, for example, if you want to print that. But now, first of all, this is a private thing, but we do have access because we are a friend function. So we can do that. We can just access all the m underscore stuff. But I just don't like putting wall dot in front of everything. Plus, you would expect this to be a member function, right? You would expect something like void, well, whatever return type, print standard ostream reference. And it's const. Now it's a real member function. If we call this and then have it have it print this class, we can simply do os and then write mrows without having to deal with the wall dot here. And this also has access to mrows because it is a member function of the class. So why is operator less than not implemented like this? Well, the reason is, and please don't leave if you already know this. I'll try to make it quick. I just think it's a flaw of C++. So I think it's worth mentioning. The way this works is you have an ostream and then you do, you write A and then you write B and then you write C, etc. But this is just overloaded left shift operator, which is left to right. So what this does is it first executes this, and the result of that is being used as the left argument of the next. And then it does this, and finally it does the last one, where really this is just if we remove the friend, it would be a member function, and then we would have something like excuse me. The point is that you want it to be this way because you wanted to write A first and then B and then C. If the ordering was different, you would get a mess. It would try to write C to B. It's not even possible. So what this does is it writes A to OS, and then this thing here returns OS. So this does OS AA, then it returns OS and then applies B to it, which also returns OS and applies C to it. So a series like this just writes A and then B and then C to OS. But if you want to make a member function of that, then OS is on the left side. So what you really have here is OS and then the operator name, operator less as a function name, and then A. Now this is completely equivalent to this. If this is a member function, then this would be written like this. And now this function is a member function of OS, which is an ostream. And we don't want that. We wanted it to be the member function of A. So what you really want is A, and then, yeah, I mean, okay, let's go ahead and write it like this. We want to write A to the ostream. So if you do it like this, you could get A dot operator OS, like that. You know, maybe Björn Strustrup should have chosen this to write A to OS. But how are you going to write B then? The only way is this, and then have this be evaluated before the other one. So you get something like this. And this would then write first A and then B and then C. Now, first of all, this is the right shift operator, which it does not evaluate like this. It evaluates also left to right. So, no, I don't think this works. Therefore, you cannot make the print operator to an ostream a member function. It must be a free function, which is why the friend is being used. But we want it to be a normal function, so I just define my print on. Now I have a member function that's going to write to OS. And then I write this thing as follows: wall print on OS. Always the same, straightforward. There's even a trick that you can leave this completely out and write something in global name, well, in the namespace where numberwall is defined in, that will implement this for us if the class that you try to write to the ostream has a print on. I use that in my project. So in my project you will not see any operator less and less than defined in classes. I only define this, and then the print on is found, and then this is constructed or used for every class that has a print on. But that's very difficult stuff, so I'm not going to use it here. I'm just writing this friend here in the class to get it working. Now let's implement the print on. So what you want to do is we want to run over all the top to bottom. So we want to run over all the rows. Int row is we begin at 0. 0 is at the top, and then less than, well, the number of rows that we have in our number wall, I guess. It's the size plus row, and then we want to print, well, each row one by one. But each next row I want to start at the next line. And I don't know what was written just before we started writing this. Maybe I should start with a new line every time. And then write that row, like that. Hey, now you see the advantage of using a class row instead of an array here. I mean, I could have replaced row with a standard array, but a standard array you cannot simply write. But a custom class, you can always define this for the custom class. And I really like, for debugging purposes, I have to add, I really like to be able to print every class to an ostream. So, yep, I'm writing it like this. Every row is just simply written to the OS one by one. And then I have to add to the class row support for that. So implementing that, return OS, and this is not a wall, this is a row, print on OS. Like that, and then print on, define that here, and that ostream reference OS const. Okay, let's implement that also in line here. Okay, now we have to write a row. Well, that means we just write all the values, right? So something like int call is 0, call is less than m values. Can't type, not size, plus call. And then we write m values call. I want to make sure though that they are space separated. So maybe I should put the space in front of it. And or, well, yeah, we can just give it a width and then hope that the width is enough. So I'm going to say standard fill. Oh wait, standard set width. That's that is the manipulator. Let's give it a lot of space. Is my terminal 160 characters? Oh, I don't think it is at the moment. We need at least 5. Let's try that. Maybe not enough. You know, with the space it becomes, yeah, 5 is enough for 99,999. That's good enough. And then with the space you have 6 characters in total. Times 16 is almost 100 characters. I don't think my terminal is currently 100 characters wide, unfortunately. For the set W, I need IO manipulator. What are we printing in the last one? We are printing m values call, which happens to be elements. Well, doesn't it suck? So we have to add another one to print our element class. It doesn't really suck, it's just every class needs one of these things. Element. And then the same thing again. I'm going to do element, print on OS, return OS. And I'm going to add a print on Yep, must be const by the way, because you know we're passing it as a const reference. So the element is const. If you try to call a non-const member function, well, from a const reference, that's not working. It's yeah, but you're not allowed to change it. If you do not add this const, and it thinks that our print on is going to change the element. Well, we don't. We just print it. Okay, let's just print m value, right? I don't care about. But what if we do not have a value? So if we have a value, we print it. If we don't have a value, let's print a minus. Okay. I've got a column there. Nothing too serious. Only half the viewers left on this all that. Ding dong ding dong ding dong dong beep. There it is, and it worked. And apparently my monitor is wide enough. So we made a row with all zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yay. And all ones, and then our initial thing below that. And let's generate the next row. Okay, how are we going to generate one row? I would say wall.generate next row. Okay, well, I already saw this, so let's print it out after we did that. So that's going to be a member function. Let me shift this a bit. A member function of this class generate next row. I'm going to implement that below the class. Maybe it's a big function. There, member function of numberwall. Okay, well, so what we have to do now is we have to find the values, well, I call it D, I think, A and B and C, and then calculate E, which is going to be equal to, what is it, B squared minus AC, all divided by D. Yes. So if D is 0, then we have a problem. How do I know what the next row is? Well, that's the size. So we have an int next row equals m rows size. We begin with a size of 3, and then index 3 is our next row. Number wall m rows here. The array, yeah, well, let's start with again a default constructed array. So I'm just going to resize m rows. Resize to, well, the current size plus 1. This adds 1 row, but it fills it with default constructed elements. So what is that going to print? All minuses, because the values are not known. So that was fun. Now we have to fill it. Let's look for the first known element in the row above it. That would be the A. So I'm going to run over columns, starting at 0. So I want to remember the column. So we set column to 0, and then we do while m rows next row minus 1. That means 1 above it is undefined, is unknown, is does not have a value. How do you say that? Let's say undefined. I don't know. Who cares? Plus call. So as long as it doesn't have a value, then we can go to the next column. So I have to define my undefined, which is part of row. No. Sorry, this is element of m rows. That's a row. I forgot my call. So 1 row above the row that we want to generate, and then the column. So that would be an element, right? So okay, well, not really. Have to write a operator square brackets for row, but then eventually element must have a Boolean undefined which returns not has value. And I just implemented here, or used here, a thing that wants to return an element from an operator square brackets, which takes an int, and being a column, also const, because it's not writing anything to our row, just reading it. So that is m values at the given column. I'll return that anyway. I'm still returning a reference to it. I could also just return the element, then it would make a copy. Rule of thumb is that if it's like 2 pointers size, then you can still do it by value. And then I think that might be the case. I don't know. Element is not that small, I think. So I have this is byte sized. This is a pointer sized. It's unsigned long, and an int is 4 bytes. So it's really 8 bytes is a pointer for me. So this is 2 pointers plus a boolean, and a boolean is at the top, which means that due to alignment, the total size of an element is 24 bytes, so 3 pointers. So let's pass it by reference. Yeah. Okay, then this should compile, but we are going to continue. Now I found the column for the first element that is not undefined. And I'm going to assume for now that the next and the next element also are defined, and I'm also going to assume that this element is defined, because in the end what we'll get is just a diagonal of non-undefined. It grows like this. So as soon as we found the first, then the others will exist as well. So let's calculate the number plane. The next number, the question mark, is, well, that's E, right? So let's call it E. Okay. Oh, I don't like capitals for variable names. I can call it E. I'll call it E. That is then B squared. Well, what is B? Okay. B squared minus A times C divided by D. So this is a stupid way to make sure that we don't make a mistake. This formula is correct, and now I'm going to worry about the other values. So A is then also a number. A is the element that we just found. So that is this. Right, the row above it, and then the first column value that was not undefined. And then we have a number B, which is the next column. And we have a number C, which is the next column. And we have a number D, which is the row above that, and col plus 1. Same column as the B. Now this m rows is returning an element. Is our number accepting an element? No. Do I want this syntax to be accepted? Yeah, why not? An element should be assignable to a number, right? But the number is just an unsigned long. Maybe I should call it element. But then I have to implement element multiplication and stuff like that. It feels like nonsense. Is nonsense, I think. So we need a conversion, automatic conversion from element to number. And we have to add that to element. row element. Here it is. Okay, so we want back a number, and that works like this. Operator number, ta-da, const. So now having this, you can assign an element to a number. It's just automatically going to convert it to a number. And here I tell it how to do that. I just want you to print, to return m value. But now I'm going to add an assert, because this would be utter nonsense if it doesn't have a value. So the assertion m has value must be true. And for that case we need include C assert. Okay, so where was I? Okay, now we have a number E. Now we want to fill it in. In our new row, I resized m rows. So it's going to be m rows, next row, and of course it's going to be call plus 1. Call is pointing to A, so it's call plus 1. Now we are at the place of the question mark, and we have to do the same thing as above, just make an element from the number E and then pass the row and the column to it for some reason. I'm not using it, but hey, it's instructive, as it were. Yeah, but now I only have one number. I'm gonna try it out what happens anyway. Oh, it doesn't compile. What? Const element is this argument discards qualifiers. We cannot call. What? Hold on. We cannot. It's not even clear to me what it is whining about. In call to const expression. Did I type const expression somewhere? What? What? Penthy, are you going to help me? See lots of question marks. I don't know what is going on here. I have the feeling that maybe it must be like this. It's probably nonsense. I don't know. Damn it. Why is it giving this error? It doesn't make any sense. The only const expression that I have here is this thing here. Definitely the only one. It is whining about this. And then something is const. I don't even see a const here. I'm going to split it up into parts, I think. Element L assigned from here. Is that working? Well, I'm happy that the scammers think that I have a popular channel. Scamming you out of your money. Are you horny? Give us your money. What to do? This doesn't even compile. That is interesting. No, I added it. Stupid bot. This does compile. And then M row's next row is what? And that should be a row, a reference to a row, I think. I think that I suppose this is went wrong. The operator square bracket. Or do we not even have that? Yeah, that must be it. So I have a row. Oh, here it is. Yeah, nonsense. Well, this is the this is an accessor because it is const, and it promises not to change anything. So if it returns a reference, it's better to itself or a variable of itself. It should return a const reference, but in this case, we just want to get a non-const reference. There was not an accessor anymore because you want to assign to it. Now we can run it. So there's our 48. Well, we had manually calculated that already. Let's check if this is correct. 1 times 48 plus 4 times 4, which is 16, is 64, which is equal to 8 squared. So yes. Then next I want to generate this one and this one and this one and this one, zip, until we get here, and then we don't have a next member anymore. So I guess we can definitely not go beyond the second last column. And that means that this one becomes undefined as well. So the row below that, we cannot even go as far as this one, because then that value is undefined. So we must make sure that the C value is not outside the array and also is not uninitialized. So now we're going to do while something, and then I can rather just begin with that immediately. Do all of that inside here. So we only want to do this if here call plus 2, which is the C column, is still less than yeah, that's going to be the size of one of those things, but I'm just going to use the initialized values here. And it must be initialized. But yeah, I don't want the code duplication, so if we can read C, then we read C. Might as well move C up here. And then if C is undefined, you can better do a hide, I think, hide user on channel. Yeah, hide user on channel. That just deletes everything at once. C undefined break. So we break out of this while loop if C is undefined. We don't even go in it if we can't read it because it falls off the edge. And at the end of the while loop, we have to increment call. And now that function is finished, I think. Well, apart from that it doesn't compile, but that's a small thing. Who's what's the joke here? Oh, initial values. Yeah, no, that's not what I wanted. Just being stupid again. I mean the number of initial values. That one. Oh, C is a number, damn it. I need the element. Well, in that case, we have to do, let's say, number C as element C. And then here I just make an element. Element, const reference, element C. And now I can do element C is undefined. Great. Well, I'm not sure if this worked, but because they look suspiciously like negative values, maybe. Is that possible? I'm going to calculate this first cross here. I think it's a negative value. So this should be, yeah, this is totally negative. So this should be 1 times question mark plus 8 times 16 equals 4 squared. So that is 4 squared is 16, 16 minus 8 times 16 is 7 times 16 divided by 1. Minus 7 times 16. Whatever it is, it's negative. So, no. Number is long. Let's make it a long. Looks a little bit better. So now the 48 still works, and the minus 100 and something is that correct? Let me just. So now we have 1. Let's try to do this with a minus. Minus 1, no. 112 minus plus 8 times 16 plus 8 times 16 equals, no, it doesn't want to do that. I'll use my own calculator here. Of course it's going to be correct, but I want to calculate it anyway, I don't know why. 8 times 16 is 128 minus 112 is 16, which is 4 squared. So that's correct. And the rest is correct as well. but it becomes pretty large at the end. This is 1, 2, 3, 4, 5, 6, 7, 8 digits. Is that going to fit if I make my width larger? Not entirely sure about that. Let's try it. No, what did it say? 9, 8, 8 digits? Got already. I think that did just fit. Oh, that's great. But it might blow up. It might blow up like crazy. I'm not convinced that this is not going to blow up. So we're going to try it anyway. Let's generate the next row. Okay, that totally blew up. This one is already larger. Yeah. Now, when do we get an overflow? Are we going to get an overflow? Really? That's not nice. When do we get an overflow here? Maybe we have to check if the calculation is correct. Assert, so we turn it around, it must work, right? So b times b must be equal to d times e plus a times c. I don't think this can still work if there was an overflow. At least it seems very unlikely. I'm going to assume there was no overflow yet and generate the next line. Still no overflow. I'm a bit disappointed that it's still random looking. Come on. Do you see what I see? All zeros. That's what I was hoping for. But it's unexpected. It's freaking unexpected. We have one line, you have these numbers, and then suddenly it's all zeros. Why? Is this correct? Is this really correct? I'm going to do one manually. So if this is a 0, then this number is for the cross, doesn't matter. This is the same column, right? There's that column, that column, that column, that column. Yeah, this belongs to this column. So this number times 0 is 0, plus this number times that number must be equal to this number squared. In other words, this number times that number must be that number squared. So the minus signs are not even important anymore. I don't think my calculator can do this. But BC can. The BC can definitely. I'm going to calculate. I think you can just do this like. That seems to work. And then we print this one times itself. Yes, exactly the same number. So the 0 is correct. Pretty awesome, pretty awesome. Now it becomes more challenging, a lot more challenging. What you have to do now is change these numbers into polynomials. I know. This becomes 8 plus 4x. I think it was plus. I don't know if it's plus or minus. Let's have a look at the YouTube of Methodologer. I want to keep this side maybe. YouTube.com. And then we look for numberwall. And there's it. Oh no, my account's going to delete it because I played copyrighted music and I show something someone else. Let me see. Yeah, you have to look at this video if you want to understand what I'm really doing. It's really nice. Is this already with the x's? I think so. Yep, it's a minus. You see, so here he had the 2, and therefore he does the next one becomes minus 2x, and here we had a 3, so the next one becomes minus 3x, and then minus 5x, minus 8x, etc. Yeah, what? I don't understand what you're asking, Gabriel, but it's definitely random and not about number walls or my program. So now we want to extend our program to work with polynomials. Ouch. Do I even want to do this 1.5 hours before I go to bed? Okay, so our element now, I'm not going to change the number, that's just a long, but our element has to become a polynomial. Okay. But the polynomial doesn't have to know anything about the row or the column or if it has a value or not. That was more specific for element. So we're going to add a new class called polynomial. There we are. You have it. Well, so polynomial means how do you call those things? Indexes or arguments. Arguments, I guess. Argument I times x to the power I. And that is summed over certain i's. So let's say the sum for I equals 0 to some number. In LaTeX notation, I think, ish. So if I is 0, then we have a0 and the x to the power 0. So that's just our constant that we just calculated, right? And we have to keep that. And if I is 1, then we have A1, which must be the previous value, no, minus previous value, times x to the power 1. So we begin with just n is 1, so I is 0 and 1. And then we have to store the AIs. So that's going to be a standard vector of, well, numbers, I guess. And we call it A. Yep, and then we assume that all these elements are being added. I mean, I even leave the x out, but it's implied. So this is the polynomial, but the vector stores just the arguments, the AIs. Okay, now let's put a private here again, because it is already private, and I want to be very certain about it, that is clear. Public. Probably going to need the default constructor, why not? What is the default constructor? The default constructor is going to be an empty vector. What does that mean? Well, let's say if I stop the vector at, let's add an example, right? So at some point we need to, this is going to for the first one here. I don't know what comes in front of this, so we'll have to start with this one. This becomes 8 minus 4x. Yep, 8 minus 4x. That's the first polynomial that we're going to get here. So 8 minus 4x. Well, that corresponds to 8 times x to the power 0. X to the power 0 is 1. Plus minus 4 times x to the power 1. In other words, that corresponds to a vector with the values 8, minus 4. And after that, I stop. The vector is not larger than this. I only have 2. But in reality, we do have more elements, of course. We have plus something times x to the power 2, plus and so on. What is this something? Well, it's a 0. Plus 0 till x to the power 3 and so on. So a vector stops when in reality it just contains zeros that follow. In other words, a vector that is empty exists of 0, 0, 0, 0, only zeros, which means equals the number 0. So this means like construct the constant 0. I have no idea. Probably historically Jesus or Joachim. What I'm going to do here is add, of course, our famous print on standard ostream reference and the friend. Operator standard ostream reference os, polynomial const reference polynomial return OS, and let's call the print on with the OS, and let's implement this thing. Well, I'm going to implement it outside class again, because it's becoming a big file, this, all the different classes and stuff. Maybe I should split it up in multiple classes. So this is a member function of polynomial. And I just want to print a polynomial, so I'm going to run over all the numbers. Let's use a different notation. Number n of MA. That runs over all the elements. One number at a time. Google is not able to stop these bots. They don't understand pattern matching. Clueless Google. Google owns YouTube, I think. So how shall we print this? Well, I think just if it is 0, it's 0. So if well, even before that probably, but okay, yeah. If MA is empty, then we print 0. Special case at the top, just do not continue. We are done with the special case. Now the more general case for a non-empty MA. Yeah, I'm afraid I'm not good with YouTube bots. If well, the value of n can also be 0. In which case I just want to print yeah, it's dubious. I think we just don't print anything in that case, right? Continue. Except when it is the first one. I do need to know the, sorry, I do need to know the exponent. The E is the exponent. The exponent runs from 0 till the size of MA. So if the value is 0 and the exponent is 0, then I print a 0. And then we're done, so I can continue. Otherwise you don't print anything and also continue. So just skipping that. And if the otherwise, if well, otherwise we just print the number, I think. And then I'm going to print as well an X. Put a space in front of it. And then if the exponent is, oh wait, yeah, we only print an X when the exponent is larger than 0. So if the exponent is larger than 0, then I print an x. And then if the exponent is even larger than 1, we print the exponent. And all of this is going to be prepended by a prefix if and only if it is the first time we print it. Do I print it? Well, this is also not true what I do here. I only want to print a 0 when there is nothing left, when there is just a single element that is 0. Might as well do this up here. Yeah. Let's make the 0 a really special case. So or MA size equals 1 and MA 0 equals 0. That is also 0. If it's empty, it was 0, but if there is only a 0 in one element, then we have 0 times x to the power 0 is 0. So now we don't have a 0 anymore. So now I just always ignore any elements that have coefficient. That is the word. Why did I call? I'm just really developing Alzheimer here, I think. If the coefficient is 0, then we just don't print the term. Otherwise, we print it, and that can be negative. Oh boy! Oh. Printing a polynomial in a human writable way is a crime. Difficult. Okay. Anyway, I'm going to have a prefix, I think. I need to know if I already printed something. Let's just make a boolean. Term printed is false. And now we did print a term. Can't even do that here. If term printed, if n, let's do it here, if n is larger than 0, no, that's nonsense. So it's like this. If n is larger than 0, I print a plus, else we print a minus. Yeah, and here I want to print minus n in that case. But only, so I really have to negate n here. I think I made my print on polynomial correct now, but let's test it. Need to initialize these things anyway. Let's make a very simple constructor. polynomial, let's say a single number. Which then creates, well, let's do it like this. That push back and the single number. And then I'm going to do n1, comma number n2. See if this compiles. Yep. Now we're going to test printing polynomial p1. It's a default constructed with a 0, constructed with a -1, constructed with a 1, constructed with a 2, constructed with a 0 and a -1 and a 0 and a 1. We're going to have 2 zeros. Yeah, of course we're going to have 2 zeros as well. And well, let's put in a 2 here as well. And then finally we have say -1 and 2 and 2 -1. Okay, I think if all this works, then it works, right? And now I wish I made an array of this, but I don't know how to initialize that then. Is that stupid? Probably, but who cares? Standard cout p1 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then you have to do it again. 2, 3, 4, 5, 6. What am I doing? 6, 7, 8, 9, 10, 11. Well, if you still know what it was, I don't. Let's memorize this. How am I going to do this? I cannot memorize this, unfortunately. Let's put it in a different console. Right, empty thing, that should be 0. And the next one is 0, also print 0. Next is -1, yes. The next one is 1, okay. Then we have a 2. Then we have -1x. Okay, so the 1 is argument is not implemented. 0, 0 is printing nothing. That is so funny. Again, the 1 as coefficient is not working. 2x, okay. -1, 2x, and 2 -1x. Right, let's fix that. unless the exponent, so if the exponent is larger than 0, only print this, and n is unequal 1. I thought I saw a -1 as well. I don't know, let's see. No, this is, yeah, this one. -1x. That's an error in itself, isn't it? Yeah, term is not printed yet, but exponent is already larger than 1. Then we have to negate it as well. So if exponent is larger than 0 and n is less than 0, n becomes -n. Nope. Well, I don't know what it does. It's missing a lot of zeros maybe. 0, 0, our -1 has disappeared. All constants have disappeared. It's a mess, total mess. All the constants have disappeared completely. Oh, we only print. Wait, no, wait. I want to print it if e is equal to 0 as well. That's what I meant. So 0, 0, -1, 1, 2. This must be -x. That's wrong. The 0 is still missing. X, 2x, -1 plus 2x, and 2 minus x. Getting closer. This is the worst one. The minus is not printed. And the space must be printed after the coefficient. Let's print it in there, why not? Well, really, yeah, it's like this multiplication thing. So it seems correct. No, not really. Okay. Might as well combine that with this thing here. If n equals 0, we just continue anyway. Now it looks good. Except that this should be a minus x, I think. So what went wrong there? There was 0 minus 1. This whole printing thing takes way too long, I have to admit. So if we have term printed is false, and then n is not larger than, why is it not printing a minus then? Oh, term printed is false, so we get here, yeah, and then it just does that. Oh boy, notice that now that again. Yeah, it was negative. It was negative. It's really not something I can do slightly earlier here. Should be able to do that here. Or not. If e is larger than 0, yeah, n is less than 0, okay. 2dd. No, finally correct. 0, 0, minus 1, 1, 2, minus x, 0x, 2x. Yeah, now it looks good, I think. I think that's what I had. I can see it here. 0, 0. 0, 0, minus 1, 1, 2, minus x, 0, x, 2x, minus 1 plus 2x, and 2 minus x. Perfect. Next, we need to fill these things in. I also need to be able to multiply and add polynomials. Let's do that first. So polynomial multiplied by another polynomial, right? Yeah, I think so. Let's just implement operator times taking a polynomial, const reference p, thank you, return this, as is always the case, I think. Not even sure. Yeah. Okay, and we're going to multiply. No, this is not correct. This is, of course, times equals. Otherwise, it would take. Oh yeah, no, I like this one better. Whatever. So now I have to multiply this with p, and then we can return this. How do we multiply two polynomials? The slow way or the not so slow way? I don't think I really have to be scared about slow, right? So let's take the slow way. Multiplying it one by one. It's not even that easy. It's definitely not easy. Multiplying with a number is easy. Let's do that first. Number in. In that case, we just run over all the MAs by let's run over it by I'll keep call it E of exponent. MAE is multiplied times N. Yes. So let's take these two. I'm going to multiply this one with 42 and 11 with -1. It doesn't know what number is yet. No, it does. Number is defined here. Oh, I put it outside class. Polynomial. No declaration matches. Really? I changed my mind 3 times, so now it's this instead of what I had. And still we don't have it, because now I've got to add the semicolon. Okay, so minus plus 2x minus 1 plus 2x times 42 is minus 42 plus 84x. And this one changes as well. Times minus 1. I think it totally worked. Now another one that is simple is adding a polynomial. That's just argument-wise, right? To coefficient-wise, I should say, p dot mae. So this add this polynomial p, then for each coefficient we just add the coefficients together. Do not even have to test that, I think. Right? Wrong. This is not correct. I have to resize one of them. If ma dot size is less than pma dot size, then ma is too small. So let's do ma resize to that size. Else, if it is the other way around, if this is smaller than that, nope, I cannot resize p. That is nonsensical. So how is it going to work then? Oh, we simply stop adding stuff. There's the minimum of those two. Oh, might as well done that immediately. It's not really necessary, because then we were just adding zeros. Yeah, so we add the coefficients for as long as they both have coefficients. Now, is there still something wrong? Namely, I should have done that. Yeah. If the p that we are adding has an x to the power of 3 and we don't, then we have to resize it and add a coefficient of that x to the power of 3 here. So this should work. Let's test this with on making a p0 that is -1, and we are making a p1 that is 1 plus x, and we are adding those two, and then we are printing the result, and the results should be, then this one is resized to two elements, becoming -1, 0, and then we add that, so it becomes 0, 1, so it should just print x. And it does. Yeah, well, I know, sooner or later I'm gonna have to multiply with a polynomial. Let's first multiply with x to the power n. So this is like multiply with an exponential. X to the power e. Let's call it xe. So x to the power e. Well, that means that everything must be shifted xe places. So we need to insert xe zeros at the front of the vector. I have to look that up. I'm sorry, but insert. I really have no idea. How does one insert zeros at the beginning of a vector? N times. Well, resizing is never a bad idea, so let's start with that. Resize. Otherwise, if you insert something at the front, it's going to shift everything one by one. So it's going to allocate, make it a little bit larger, and then shift everything. And then if you add the next zero, it's going to do that again. Multiple allocations, multiple shifts. This way, I just am sure that we are doing a single allocation. And yeah, why not a single move? I don't know, there's probably a better way to do this, but tell me in the chat, I would say. Right, someone said something. Wait a minute. You can use the int multiplication and the polynomial plus equals to implement the polynomial multiplication. Yeah, that's why I'm adding them. I also need this, I'm afraid. So that's MA. No. We're going to run over the pseudo exponentials, starting at the end. So the new size, -1, down to xe. Sorry. I think that's okay. Minus e. And then MAE becomes MA E minus xe. Yeah, well. Yes, no. I think we're almost done. I don't think I need anything else than the multiplication of two polynomials. Is this correct? Say xe is 0, so that shouldn't do nothing. Then the resize is doing nothing. Xe is 0, that means that's going to copy itself, so it also does nothing. And this also does nothing. And if xe is 1, then we size it 1 up. And then while e is larger than xe, I can still subtract. This is not correct. So it must be larger or equal than large. Yeah, obviously. Okay. Well, let's do a little test. So I'm going to have, let's say, minus 3 plus 4x. And then I'm going to multiply that with x to the power 4, x to the power 5. Oh yeah. Now what? Must have an argument of blah 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 blah. Polynomial. Well, keep making the same mistakes. And still not. Warning, no return. Yeah, that's also an error. Return this. And then we had a minus 3 times x to the power 5 plus 4 times x to the power 6. Because I multiplied with x to the power 5. Yeah, that worked. Now finally we are going to multiply two polynomials, I think. Let's use 2 and 7 here. And implement that. It's my polynomial. There it is. Polynomial, 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 polynomial. Yeah, we are there. Why? Let's multiply with a polynomial. And then implement that as well, somewhere at here, for example. And then so that I can see my class, as if that matters. Let's not forget to return this time. Okay, so how does that work? Yeah, well, okay. Roy, tell me. How can we do this? I think I need to make a copy. It's not even that good, I think, to have this kind of thing. Let's make it a binary operator. So now it's a free function. It's not a member function anymore, because the friend here makes it a free function outside of the class, and then it takes 2 arguments. Multiplication takes, yeah, left and right argument. But we can access MA, even though it's private, because it's a friend. So now we are going to implement this here. Free function. Operator. Now we have a return polynomial result. Return result. And yeah, I still have to implement it now. Now finally we have to implement it. Implement it. So this is a binomial thing. If you want to do it fast. I'm stupid. I'm just going to implement it the stupid way. Hope nobody cares about that. Otherwise I have to, do a little research, figure out Google and stuff, ask around on Stack Overflow. You don't want to watch that. So let's do it the stupid way. I think we're going to run over both arguments of both polynomials. So I'm going to do, we have an E1, and start at 0. E1 is less than the P1 MA size plus E1. And the same thing for the exponent of, oops, of the second one. Now imagine that P1 is say 4 plus 5x plus 6x squared, and P2 is 1 plus 2x plus 3x squared. And we're running over the coefficient, so P1 runs over 4, 5, 6, and then E1 and E2 runs over the MA values, at least 1, 2, 3. Then kind of obviously we have here the result. MA have to resize the thing as well. The largest coefficient in the result is going to be x to the power 4, which is just, and the size is 3, so the size minus 1 is 2, and then we add those two, and that is 4, and then yeah, so the size becomes, can I pass a size here? I don't think so. Let's just resize it here. Result MA dot resize. It's going to be P1 MA size plus P2. What I'm making a number wall for the number of solutions on of an elliptic curve over finite fields with characteristic 2 and 2 to the power m elements and blah blah blah. So kind of I don't know, adventure. MA size. I probably should add a size to something. Yeah, let's add a size to the MA, and the MA is a no, the MA is a, let's add a size to polynomial, because that's called a degree. Int degree. I think the degree is the highest exponential of the whole thing. So the MA size, well, it's not really if the last element is 0, of course, but who cares? I mean, I'm going to call it I'm going to call it simply that degree. So in this case, if the 0 is here and the array is this big, then the size of the array is 3, and I'm going to call the degree 2. Maybe I should not call it degree, but size. Yeah, okay, I'm gonna call it size, because it's just otherwise slightly ridiculous. Anyway, now I have a size. Can make this a little bit smaller. Oh, it's resizing it, right? Okay, so the probably -1 or something. Yeah. Must be 1 larger than the degree. And the new degree is the sum of the degrees of the other one. So this one -1 plus this one -1 plus 1 is this one plus this one -1. And then we get here the coefficient of E1 plus E2 is going to be the multiplication of those two. But we have to add that to what it already is. So I'm going to do the let's say E1 is 0, so that would be 4, so that's P1 dot MA E1 times MA E2 . Is this correct? I think so. And this assumes, of course, that the resize fills it with zeros, but that's what it is doing, isn't it? Because our polynomial it does not store elements, it stores numbers, which just becomes 0. Instead of undefined nonsense like that. I'm happy with this. Let's just test it for this thing here. We're multiplying two difficult things. Let's print them out as well. Times, well, really. Yeah, we cannot do that. We can only do free function, binary operators. But I want to do this in this case, and then I should be able to. So I can just add it anyway now. And then I can implement this in terms of the free function. I'm not sure if the friend has to go above that. I think it considers the whole class. There's going to be a return with this again. And then we have this times, no, what did this becomes? Oh, yeah, I have no idea, man. How do we do this? Times when it's easier the other way around, but didn't want to do that. Okay, I won't do this. Polynomial P2 is P0 times P1. That should work. Okay, -3 plus 4x times 2 plus 7x equals -6, yes. minus 13x. So that is minus 21 plus 4 plus 8. Yeah, that's correct. Plus 28x squared. It's just correct. It works. Oh my god. Yeah. Well, that's nice. It's nice that it worked. I think we have our polynomial class. It took a while, but finally we have it. So now I'm going to go up to elements and turn element into a polynomial. So current our element is a single number, but I want it to be a polynomial. But I explained at the beginning of the stream what I'm doing. I'm just going to change this in polynomial. You can also say I'm demonstrating the power of object orientation. We began with something that was ridiculous, wrapping an integer inside a class. And I'm turning it into a polynomial. How about that? Okay, so we're passing a number here, and a number can be passed to a polynomial because a polynomial has a constructor that takes a number. That's my class. Yeah, takes a number. So this is working. Amazing but true. Returning a number is not going to work because, well, it could be not a number anymore. So we're converting this to a polynomial. Element can be converted to a polynomial. We can still print it. You see the power here of the O stream. I had this, it still works. Imagine I would have written for loops and whatever to print numbers. Could not have switched to polynomial like this then. This is how you do it. Standard array, values. Well, yeah, well, a row is still existing of elements, and this is a different value, by the way. No, values. I don't know. Is this going to go wrong somewhere, or is it just going to work immediately? What do you think? I'm going to try to compile it. Cannot convert element to number in initialization. Oh, right. These numbers are also polynomials now. Ooh, I needed... oh, no. I need a division. You need to divide by a polynomial. Painful. Painful. And not done yet. Okay. Really? Substitute a number with polynomial. Yeah, division by polynomial. Oops, well, yeah, oh, yeah. And this is this going to work? Element, yeah, this is just simply assignment. Number wall, generate next row. This can be deleted because we're done with polynomials. No, we're not done with polynomials. We still have to test it. Division. Implement division. Let's first just try to compile it, and it says no match for operator minus. Oh, I also have to implement. This is ridiculous, of course. Oh no, it's not. No operator plus, no operator minus. They're both not. It's not even talking about the division yet. And this thing wants a polynomial as the first argument. Cannot blame it, but what is E? Let's have a look there first. E is a polynomial, but it's undefined. It didn't understand the minus, so it doesn't know what E is, so it's going to complain about it. Yeah, Oh, that was Dutch. Okay, let me think. Okay, I have thought. And we're going to polynomial and then implement 3 functions for absolutely random order. The minus, what am I doing? Undo, redo. Minus and the plus. Almost the same as multiplication, so I just copy it here. Okay, this one is easier. We can just implement this one in the other one. So polynomial result, and then return result, and result is simply copied from P1, and doing P1 plus becomes P2 result, I mean. Yep, that works. And the other one is almost the same, but the minus here, which we did not implement. Let me implement it. I could just multiply it with -1, but I think I'm going to implement this one separately by copying it. Dirty programming at work. Minus. Minus. Enormous change. Right, so now it's going to complain about the division, I hope. No, it's still not. Well, yes. Okay, it doesn't know that one. It also doesn't know how to compare those things. Okay. We keep adding to polynomial. We need an operator to compare those things. Bool operator. Let's also make that a friend. I mean a binary. And if Okay, this is slightly nasty because you would say I can just do if the sizes are unequal, then the thing is not equal, but they are not canonical because it could be that the size is larger, but that the excess coefficients are 0. So really what I should have is make a canonical function, I think. Make canonical, that would be nice. Is there anything that can result in the highest coefficients being 0? The minus could result in that. Addition also, I have to say. Multiplication even, if you multiply it with 0. Well, yeah. Shall we make it, shall we canonicalize the polynomial after every operation? In most cases it's not necessary, I think. Decisions. But since it's just a little test program or fun program, it's not that important. I'm not going to worry too long about it. I cannot canonicalize P1 and P2 here because they're const, they're passed as const. So I just have to deal with it, I think. I could canonicalize it in the other functions. And then it would be slightly easier to compare these things. No, I'm just going to deal with it, I think. Okay, so we're going to run over all the exponents. E equals 0, E is less than standard minimum of the sizes of both. If P1 MAE is unequal P2 MAE, return not equal. Yeah, and otherwise they are unequal if anything is unequal 0 in the remaining stuff. I need to know which one is larger in that case. So annoying. Annoying code. The largest polynomial is of course P1, unless it isn't. Can I not just do this? P size larger than P2 size. Return. I will never be able to remember the what is it? Precedence of these of this question mark thing. Anyway, now LP points to the largest one. And then we also need to have the sizes of both. So actually it's returning an int now. So S1 the smaller of the two. The smaller size is this. And then the larger size of the two is the maximum of the two. For int e is the smaller size, e is less than the larger size, plus plus e. If the larger polynomial, which is a pointer, ma, e, is unequal 0, hope that works, return false. If it survived all that, then they are equal. Okay, standard min and standard max are defined in algorithm. Include algorithm, I think, anyway. Nope, and oh, that's still the division. No matching function for call to polynomial. Yeah, it's being constructed from a number, not from a polynomial. It's probably not what we wanted. Okay, this is definitely not what you wanted. Polynomial. Const reference. Yeah. So normally I would do this by value and then a standard move and then add the move assignment and constructors to polynomial and stuff like that. So this is not super professional C++ coding, but it's still fun. VI. Okay, we're just down to the just division. So I can go to bed in 3 hours. How are we going to implement a division for polynomials? Especially since all the arguments must remain integers. Is this even going to work? It should work, but I have to say, how? I don't think it's difficult actually. It's just really weird that those coefficients are integer and stay integer. Yeah, Mr. Peekaboo, I'm sure, but I have to do this before I go to bed, and I'm pretty sure I can implement it myself faster than learn the API of some new library, which you don't have to integrate with the current code. Plus, we're talking about what is the word? A polynomial with an x in it. What is the word for that? If you work with that, symbolic or something like that. It's not. I don't even know it. A simple library from the top of my head can do this. No, I don't know. I'm just going to add it. So we have multiplication, and now I want to have a division. So very simple there. So this compiles, but it doesn't link, I think. Great. So I still have to implement it. Could even brute force it. Just try every... No, that's nonsense. Okay, let's implement this. I'm just putting it at the top here again. Why not? Almost done. Okay. The thing that worries me the most is that it is so extremely counterintuitive that this would return integers that you can hardly believe that that's going to be the case. I would put my money on that it doesn't return integers. It's like, come on, how is that possible? Take two polynomials, divide them, and then the result would have integer coefficients? No, 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 never, never. But, okay, let's say P1 is... I don't know, let's print it out. Print it out. No, the out. Standard C out. We have to divide P1 divided by P2. That's what we have to do. Wait, before I do that, let's stick to a single row. Let's delete this, or at least comment it out. Coordinate. Oh, the assertion fails. Yeah, of course. I'm not happy with the 48 divided by 1 example. I want to have something a little bit more complex. Oh, well, this doesn't work until I have the division working. But we didn't add x at all yet. Should do that first. See, now it's only trying to divide by 1. We can do that one. But I have to make this 8 minus 4x and this 4 minus 8x, etc. So I have to change the first row. How to do that? Let me think. Okay. Let's do it here in the constructor immediately. I mean, that seems logical, and we can do that. That means I'm going to go to the fill. Yeah, we're calling fill on the first row and then the second row. I mean, that gives us 1, 1, 1, and then below that 4, 8, 4. That's how it begins. And I will be able to make this minus 4x, where this 4 is this 4, and here minus 8x, where this 8 is that 8, and so on. But if then I want to calculate the polynomial that comes here, it's going to depend on this value and that value. And I'm not sure this one's correct, because it should have like minus something x, and that something might not be 0. So let's start with this value here. And to make sure that it starts with this value, I should probably make this value undefined. Or not even put it in. Which means that, no, I can probably better make it undefined afterwards. So I'm going to fill it with the initial values, and then I'm going to do m rows. 2, 0, set undefined. Does that make sense? So m rows is this vector, and 2 is a row, and then the row needs a square bracket operator. And it has that, and that returns an element, and then element must not be const, and I don't think it is, it's probably this one. And then we have a set undefined on element. Void set undefined, not const, on element, which simply sets m as value to false. Likewise, you have to do that at the end, which obviously becomes the number of initial values, which is not here, number of initial values minus 1. It's the last one. Can I already print this? See if that worked. I added weird dots here. That's not. Yeah, so the 4 here has now disappeared, and the last element here has disappeared. So that's good. And then, of course, I have to subtract this row from times x from yeah, well, you understand what I mean. So that is going to be something like 4 int going to be a column 1. Column is less than so what column is this? So just less than this value, right? Plus call. And then we're going to change this dot m a. That was still from when I thought that the coefficient was an argument. That's why it's an a. Crazy. Call. So that column becomes becomes something. It becomes, we're going to subtract something from it, for, a polynomial. And the polynomial is polynomial is going to be 0, minus the previous one. Call minus 1, except that's well, I just want to not the x thing really. So I don't know. We can probably rather run the other way around. So let's. I mean, I'm changing it, and then using it again. That's not the idea. Let me just start at this value, and it must be larger than 0. Minus call. I don't know, let's just try it out. It's no remember, yeah, what? Oh, I'm an idiot. I worked too long on the polynomials. There's no MA here. Start to do things like that. Just really should go to bed. Yeah. No match for operator minus. Print type is element. You cannot subtract a polynomial from an element, it says. Well, that's annoying, but I can access maybe directly the element. Sorry, access directly the polynomial. Well, we can, but only as a copy. I'm just going to add a polynomial accessor. I'm getting really dirty here because I want to go to bed. So it's a non-const member function to access this polynomial here by reference. Take a random operator, the dereference operator. So where did it go wrong? No, nobody knows. Wait. Match operators minus. Yeah, here. Yeah, dereference operator. Ta-da, fixed. Or not. Not fixed. Wait a minute. This is where you have to start thinking about using Clang. Oh, that minus. Oh, that minus. Element, yeah, okay. So I want to get a number from it and then apply the minus. Static cast. I just cast it to a number first, which does work. And then again apply the minus. Or not. No matching conversion from starting cost from element to number. What the hell, man? Oh, yeah, no, of course, it's polynomial. Harry, there's no number inside there. Yeah, well, what did I change? Something with the static cost. So this I can cast it to a polynomial, and then I can probably not do the minus. I just have to fix polynomial again. Nope. Polynomial the operator minus something like this. Result is copied from this, and then we run over all the elements and negate them. Cannot assign to return value because function returns a const value. Wait, is that true? Yeah, MA is result. It should have been done on result.ma. This is const. No matching constructor initialization of polynomial. Candidate constructor not viable, no known conversion from that it's totally true. Yeah, that's because I know that this polynomial was a number, but it doesn't know that. I have to add something else and casting it to a polynomial, I think. It's a scalar. Okay, so just get a scalar. I know it is a scalar. We added an assert to make sure that it is a scalar. So this is an element, and I'm going to say as scalar or something like that. Scalar. No, scale is not the right word. Const. Yes, constant. So a constant returns a number, then I can negate the number, and then we construct from that number times x as polynomial, which you then subtract from, etc. Yeah, that should work. So I need an s constant on my element. Element. So this thing is going to return a number as constant. And that's going to return the polynomial as constant. So then we add this to the polynomial. Are we there yet? Yep. I'm just going to say that this thing needs to have a size of 1. Was it very stupid? Ah, that's probably correct. So MA size has to be just simply 1, so that we only have this, which is a number, if you ask me. Yep. Non-void function does not return a value. Okay, what happened? Okay, it printed out something that is so long that it takes almost 2 lines. And that's the part that I have to check. There was a 4 here. There was a 4 here, so this must be minus 4x, and it's a plus. Plus here, and this 4 is added here as a 4, and it's totally everywhere a plus. There must be a minus. Where did that go wrong? Doesn't make one bit of sense. Oh, idiot. I'm having a minus here, and then a minus here. I didn't even need the minus here. Or I can just do plus. Plus here and a minus here. Both will work. Now we have the right value. So x minus 8 minus 4x, and then the 8 here is a minus 8x, and the 4 here becomes a minus 4x, and the 16 minus 16x, and so on until the 16,472 becomes a minus 16,472. And then finally we get some real stuff here. It wants to divide this polynomial by 1. Well, I think I know what that is. So this should have been just filled in. So let me construct a polynomial that is equal to 1 here. Static P1. And then I can do if if P2 equals P1, then result equals P1. Dividing by 1 is just nothing. So it gets a little bit closer. What the hell? Oh, I didn't tell that it's a polynomial. Polynomial. I want to make it a const as well. Const. That didn't work. Why? It prints it out. It prints out. What am I doing wrong here? Prints out P1 is complex and P2 is 1. I guess this is failing, but why? P2 is equal to 1 failed. That's totally 1 here. Still it's failed. Time for the debugger. Break main, run. Oh no. Generate next row. That fails. Yes, it fails. Run again. Next step. Next resize, call, while. What is this doing? Oops, I forgot to step into the division. I might as well put a breakpoint here, man. Come on. Hop. Print. Break. Run. Yes. Continue. Print P. Vector of length 2. Oh, that's X, not 1. Yep, it's bedtime. It's completely clear now that it is bedtime. What an idiot. Yep, much better. So now we do get the whole row. It simply printed out these polynomials here. So the division by 1 works. If now I add another generate row, cannot do this anymore, of course. I'm going to do one more row. It is going to tell me what it tries to do, namely this. So now I have a nice example. Trying to divide stuff by linear polynomial. Okay, so now implement that. Operator division. And our example is, for example, this. Well, what I'm going to say is that obviously the units are this divided by 16. You know that. Units, the constant, I mean. The constant is this divided by 16. So it should be divided by 16. Otherwise we don't have an integer. 122,880 divided by 16 is 7680. So the answer is 780 plus let's say C1 times x plus C2 times x plus x squared plus C3 times x to the power 3. Yeah, that's it. Times 16 minus 4x equals this thing. So that means that I can calculate C1. If we multiply this out, yeah, well, easy is different, but it's definitely solvable, right? How can I solve this fast? So we begin with we begin with unknowns, and then C0 equals that, because it is this one divided by 16. Now I can multiply this thing that I am dividing through. I can multiply that by this value and then subtract it from this one. No division needed. So then we get this C1 equals, sorry, times that equals, well, this thing still, the same thing, minus C0, which was this, times this, which I can calculate. And then this drops out because it's equal to 16 times that. Drops out. And then we have minus minus, so it becomes larger. Calculate that. 40960 is negative, and that becomes larger. So 4 times 7680, 10,240. X, and we accounted for all of this. Yep. And then we can divide everything by x. And then we have another division, but of a 1 degree lower. So now the 10,240 better be divisible by 16, and it is, of course, because we see the 1024 in there already. Divided by 16 is 64. What? Must be divisible by 10. 1024 is 0. Divided by 16. 640. So C1 is minus 640. And then rinse and repeat. Yeah, I think I figured out an algorithm, but now I have to write it. Now the C0 and the C1 are equal to the result coefficients starting at, I don't need this anymore, even division by 1 is going to work. I don't even want to print it anymore, just it's too big anyway. So I'm going to run over a little bit, I don't know, let me think. Let's just push back everything. So then do I even need to know it? Polynomials. I'm going to change this one, not P2. Let's make a copy of P1. Or yeah, probably, well, it's easiest, I think. So I'm going to make a copy. Let's call this is that called the enumerator? I don't know. I want to have it correct. Enumerator. What? Someone help me. How do you call the thing that's above the division, the bar? The denominator, maybe? Nobody knows. Nobody answers me. So you have A divided by B. How are A and B called? Like one is a denominator or something? Denominator. Denominator. Yeah, this is what it is. Yeah. Numerator and denominator. Okay, thank you. So P1 is the numerator, and then I need a few operations. For the start, I need to know if it is 0. polynomial. Still not done, the bloody polynomial. Is 0. And I need to get the lowest coefficients, so the constant. Get constant. And we need to be able to divide it by x. I think I already had that. Or not. Yeah, there was a multiplication here. If I do this, so -1 is not working. I'm just going to make a special case. Void divide by x. What else do we need? I think that's about it. I'm going to implement it right here in line because, damn it. Better idea. Assert is hardly necessary, but to make it a self-containing function, we demand that the constant is 0. And then we can just loop over all the elements. Oops, +1. And why not resize it? Although we can only do this when the size is larger than 1. Well, let's check that above here. If MA is empty, then we do not do anything. Otherwise, I can simply use MA0 here. And then the resize will also work. Looks correct. Divide by x. Yeah, empty is nothing. If it is, the constant must be 0, and now we replace everything with one coefficient up. maximum one is size minus 2. Yep. Clearly E must start at 0, and then we're going to find C0, and C0 is equal to the constant of the numerator so I call that, right? Get constant. Yep. Divided by I use parentheses here. Here's a parenthesis. Here too. Here's parentheses. Result MAE becomes the numerator get constant. That would be this one, divided by the constant of P2. I'm going to have that a lot, so I'm going to call that one the P2 constant. Which I just initialize quickly-ish. Number, the P2 constant is P2 dot get constant. Well, yeah, okay, assert the constant is not 0. Because we're going to divide by it a lot. But also, before we even do this, I'm going to assert that it is divisible by that. So in this case, that divided by 16 is C0. And then we have to divide the numerator by that constant times P2. Yeah, now multiply. Yeah. I'm going to make a number. Is that possible? Yeah, but it is a number. The number is, let me see. Well, CE is this thing. And then I need I'm just going to make a copy. Polynomial, I don't know how to call it, PF copy of P2. Now we multiply PF with CE. So now there was P2, this PF is now this, and I multiply it with that number. And then we subtract that from the numerator. Numerator minus becomes PF. And then the numerator must be the divide by X. And then we get this. So then we can start over, and then we get C1. With starting over meaning that, yeah, I'm just going to determine the next C. So we increment E. And then we go to the top. Might as well make that a for loop then. You still need to stop at some point. When do we stop? We stop when the next CE is definitely going to be 0 because the numerator became 0. So until not numerator is 0. Well, let's hope that that worked. I'm gonna keep these numbers for now. Cannot assign to return value because a function returns a const value. Cannot divide by X in a constant function. Wow, it compiled already. That didn't work. Didn't work. Run. We crash here because nobody knows. This is so stupid. Why? What is the use of this? Just print it. It cannot divide by 1. Ah, right. Oopsies. I'm just growing it one by one, right? So I'm just going to do push back. Result, yeah, that seems correct. Am I completely crazy here or not? Well, nobody knows, but we had this secret assert that we did comment out. This one. If this now, I mean, the division is nobody knows if it works. I mean, I just, you just saw it. But if then this works, then this worked. Period. Let's hope that we do not assert. We do not assert. I wrote just a division that works. Evil laughter. I'm going to conquer the world and know it. Next, we're going to add, how many did I have? 4 or 5? I've God, horrible. There are our zeros. 0, 0, 0, 0. Well, that means, my friends, that one of these things is a polynomial. Okay, I would really like to see them all on one line, maybe on different lines, so I can actually see what they are. They have to be the same apart from a constant, I think. Right? Oh, I'm not sure. So here you have 114688 and then again 114688. And there's this same thing. This one is smaller. I would like to know the greatest common divisor of this, to be honest. 114688 divided by 28672 is 4. I have a good feeling about that. Yeah, probably have to divide everything by this number. Well, everything of the first polynomial. Can BC do that? I don't know. BC. Can BC work with polynomials? I don't even know. I don't think it can, actually. It can try. No, it doesn't understand that. Okay, but it does understand dividing this divided by this number. So that's -4 and then +4, and this is of course 1, and this one divided by that number is that. So our polynomial really looks like -4 plus 4x minus x squared, and that was a 2, plus 2x to the power of 3 minus x to the power of 4. Yes, multiplied by this vector, and hopefully all the other polynomials are exactly the same form, so we can test that by the coefficient of the square and the power of 4 should be the same. So let's look at this one, and they are. See, those two are the same, and this one should be twice as large. So let's say print this one times that one times 2. Yep, that's that. And then we have these, so should be the same, no minus and plus, and that is 4 times that thing. Yep. So all these polynomials are in fact, apart from a constant, this polynomial. And now the magic comes. Now the real big magic comes. Solve for x to the power 4. So I'm going to copy this. We're almost there. You're going to be amazed. It's really worth not going to bed this. So what we found was this polynomial. Now solve for x to the power 4. And that is 2 x to the power 3. I'm also turning it around. Minus x to the power 2 plus 4x minus 4. Yep. Now we can say the next term Sn, equals 2 times Sn minus 1 minus Sn minus 2 plus 4 times Sn minus 3 minus 4Sn minus 4. Bang. Let's check that. For example, we started with these numbers, right? So let's begin here, and then I'm going to predict what the next number is after that. So how many do we have? 5 in total. So four arguments gives the fifth. So we're going to start with these. And that should give 44. Where are we? Here. I still don't believe it myself. Really. Okay, this. So this is minus 4 times 16. 4 times 4. As a plus. Then we get 8 here is a minus 8. And a 2 times 4. Do I do that correct? No, I'm not. Yeah, no, I'm not doing that correct. It must be the other way around. Sorry. The 16 is the largest one. So yeah, I have to turn it around. So as this is 16, of course. This is the 4. This is the 8, and this is again the 4. And then we get 2 times 16. 2 times 16 minus 4 plus 4 times 8 minus 4 times 4 is 44. That worked. Now we get 4 of these 4 here. 1, 2, 3, 4. And when I'm going to predict a number that we don't know, right? I mean, I know it, but it's not here. So we have to look it up. Let's do it with BC. Oh, I don't see my program anymore. BC. I want to have these numbers reversed, multiplied by, so I can just do it like this, of course. So plus 2, minus 1, plus 4, minus 4. Yep, so this minus 4 times that number plus this 4 times that number minus that number plus 2 times that number. And that is, gotta be fucking kidding me. There's a multiplication missing there. Times that number. This is the result. And now we're going to the website. So the last number was 65,088. 65,088, and the next number is 130,972. Bang. You! This is so awesome. Really awesome. So that's it's amazing. Plus, what methodology also told. So this is basically this. You have to really watch this now. He also said that if you have a number wall like this and it ends in all zeros, you can you have a formula like this, and also you can make a real formula for it. So we can derive from this a formula where you plug in m and you get out. You get out the result. You do not even have to do it recursively. Now, if I want to compare this with the solution that I had, which I did not understand, looks different. I don't see a 4 in it, for example. It's also a recursive function, but yeah, I'm not sure what this is. If it returns 3, so I think you have to do 3 is this returns a 4. Oh yeah, it's 2 times what it returns plus 2. So the 3 corresponds to the 8. So that of course has an influence on the recurrence formula. It's probably the same thing, I guess. Although this one has a constant, and then that's a constant. It's also weird, but well, it must more or less be the same thing, I guess. Sort of under the hood. But now I know how to generate it. That is super awesome. So now you can do that for, let's say, other numbers as well, because this is I had brute force calculated the number of solutions on this elliptic curve. And then I just by looking at this and pen and paper, I have figured out eventually, well, with a few programs, I must say, yeah, and pen and paper a lot, but also writing computer programs, of course. Man, this formatting is absolute horror. No, it does exist. You just have to tell it to load the image. Ridiculous. The point is, this is done for, let me see. Pretty sure it's, yeah, b is 1. There it is. B is 1. So what I did before, I mean, obviously, here's the full elliptic curve. So you have a coefficient a and b in it. And I figured out that the value of a doesn't really matter. The only thing that matters is the value of the trace of a. The question is, how many x and y pairs are there that form a solution to this equation? And then what I did was I figured out that the number of solutions, there is only a solution, and the trace of x plus a plus b divided by x squared equals 0. And so that in the end you can say that the number of solutions is equal to the number of values of x for which the trace of x equals the trace of b divided by x squared times 2 plus 2. And then I picked b equal to 1 in order to let m drop out, because m here is the number of bits that you work with. And if you change the number of bits, then the whole thing changes so much that none of the b values can even compare between different values of m, except b is 1. So by picking explicitly b is 1 and a is 0, because it's really, for the count, it does not matter what a is. Might as well pick a is 0. Then I had something that, it probably, must have some meaning. However, it was excruciating difficult to find a formula for it. And what I would like to do is fill in b is, t, for example. That should work as well. Then explain what t is. What you do is you make a polynomial, preferably of a low number of terms. So in this case we have 3 terms. You can always do it with 3 terms or 5 terms, but for all the small values of m, it is always a polynomial of just 3 terms. That you set to 0. So we have, say, m is 8. We have t to the power 8 plus, and then some k. You have to figure out which k. Plus 1 equals 0. Then t is a root of that polynomial, obviously, because if you fill in t, then you get 0. You set it equal to 0. Now, that root is just a complex number. But doesn't mean that you can write it out. I mean, it could be impossible to write down what t is. You only know that it has to be a root of this polynomial. So t is a complex number, but you don't really know what it is, except that it is a root of this polynomial. But then we define the finite field that the x and the y and the a and the b also are an element of, as all polynomials of degree m minus 1 that have coefficients from the Z2 field, so 0 or 1. All the coefficients are 0 or 1. And the funny thing is that then you can multiply 2 polynomials, and every time you multiply 2 polynomials up to a degree of m minus 1, you might get a polynomial with degree up to 2m minus 2. But you can every time replace a t to the power m with t to the power k plus 1, or minus t to the power k minus 1, but since the coefficients are z2, minus 1 equals 1. So t to the power m equals t to the power k plus 1. So you can reduce all the higher coefficients of t until you get something lower than that, which means that this polynomial is called a reduction polynomial, plays a function of a modulo, and the result is that you just simply always end up with a polynomial of a degree lower than m, even after multiplication. And then, since each coefficient has is 0 or 1, it's like a binary word of m bits. So you have 2 to the power m possible values. Let's say m is 3. Then you have t to the power 0 and t to the power 1 and t to the power 2. And the coefficients thereof, 1, 2, 3 coefficients, each of which can be 0 or 1. So a total number of possible polynomials, or 2 to the power 3 is 8. And you can multiply those just like you would multiply a polynomial. And then you use the fact that t to the power 3 can be written as, let's say, k is 1. So every t to the power 3 equals t plus 1. So you can reduce every polynomial until you have, again, a polynomial with a degree lower than 3. Hence that it is a closed field with 2 to the power 3 elements. It's very, very interesting stuff. And on using that field, you find number of solutions of this, what is called an elliptic curve. And then we can start to do crypto with that. Anyway, yeah, this is my reference manual of libECC, which stands for Elliptic Curve Cryptography. But I definitely would like to do this again now for B is 1. But then I'll first have, sorry, for B is T. And then I'll first have to brute force find the number of solutions with brute force, and then we can use this program to find the extension thereof. And as you can see, it's very simple. I mean, this is very simple. We just have 2 and minus 1 and 4 and minus 4. It's super simple. And it could be that, say, if I try out t and maybe t squared and, you know, stuff like that, they all result in something simple. And then maybe we can guess what the formula is for an arbitrary b. Well, that was my goal. That was my main goal at the time, but it was 14 years ago. Yeah, I did give up. But now I have hope again. Now I saw this video of mathology. I'm going to bed. It's late. In the description you see a link to Discord. If people want to continue to chat with each other, you can go there if you want. I didn't look at Discord because OBS is over it. Let me have a look. Is anybody there already? Oh, I see already lots of people. Okay, cool. Hi, everyone. Okay, man. Yeah, thanks for watching. I hope people thought the ending was worth it. Finding this recurrent formula for the number of solutions on elliptic curve. I mean, what the fuck? I kind of, after seeing the video of Mathologer, I had a feeling that it had to work, but all this time I couldn't believe it. So I'm really excited that it really did work.